Hello everyone, I'm Satvik and today I'll be explaining you regarding life expectancy prediction project. In this video, I'll walk you through the steps I've taken here in my Jupyter Notebook and evaluate the life expectancy prediction model. Let's start by looking at this Jupyter Notebook. As you can see here, I've organized my code into different sections to make it more readable and easy to follow. Firstly, I've imported the necessary libraries and load the dataset containing various features related to health and socioeconomic factors. You can see here adult mortality, infant deaths, alcohol. There are various features given in this dataset. These are all the features you can see here. So when I describe this data, you can get here count, mean, standard deviation. I'll be using the basic library functions from pandas, and here you can see that I've converted this categorical feature into a numerical one from developing as 0 and developed as 1. Next you can see here regarding the missing values. As you can see, a lot of missing values are present in our dataset. So moving on, I perform an exploratory data analysis to gain better understanding of the data. I here visualize the relationship between different features using scatter plots, bar charts, and correlation matrices. After all the analysis, and handling missing values, you can see here a function is being used using import numpy as np and t. To fill the missing values, what we used here is a random imputation method. As you mentioned here, we created a function that takes the pandas data frame, identifies columns with the missing values, then imputes these missing values with the random values. It takes the maximum and minimum of each feature, maximum values and minimum values of the feature, and generate a random value based on the function. And with this, we can fill all the missing values. What comes next is the exciting part, or what most people want to do the most. That is building the model. So I've chosen a linear regression prediction model for this, and it's simple yet effective algorithm for predicting continuous variables. But before that, we do have some feature engineering. As you can see from the correlation, here's the correlation matrix heat map for all the features. You can observe here that GDP and percentage expenditure have a 0.9 correlation. Similarly, you can observe that under 5 deaths and infant deaths have a highly correlated. Thinness 5 to 9 years and thinness 1 to 19 years are highly correlated. You can see here. So the best thing is to drop these values. Either drop in under 5 deaths or infant death. I'm dropping infant death. The same with here. I'm dropping percentage expenditure, and thinness 5 to 9 years is dropped. We drop these three features, and now, as you can see, there is no these three features in this dataset. And after that, it comes out training regression models. As I mentioned before, I've implemented a linear regression model. We split the data into training set, testing set, and validation set. So first, the model is fitted to training set. We perform some evaluation metrics on validation set and the testing set. As you can see the result here, mean square error being 16, root mean square error being 4, r square is 0.8. So is the testing set. We do some analysis and then combine the training and evaluation set to fit in the final model. And after fitting, you can see here we did to check the how accurate the model is. This red line represents the zero residual, means the accurate prediction, while these blue dots represent our actual, like what the model has predicted. As you can see here, most of the blue dots are near our red lines, and there are some scattered values, but it is what it is. So it's pretty much 60-70% accurate. We have some outliers, which maybe if we have applied a random forest model, k means k nearest neighbors, maybe these models can better handle these outliers. But since we've used linear regression models, a simple basic linear regression model, we find a bit more outliers than compared to other models. Next, we will look at some scatter plots, drift plots, and this is what we conclude in our model. The coefficients, how life expectancy changes with regards to our features. You can see here from the coefficients. Year is having a minus 9.5 to the power of 10 power minus 3, basically saying that when you reduce the year life expectancy, like they are inversely related. Status being 1.5 means a positive value. Since status is either a developing country or developed country, one being developed, so more developed a country is, the better the life expectancy. Similarly, yes, you can go through this. What we'll do next is we'll save the model by importing the pickle, and you can do some predictions here. Once the model is trained, like after using the evaluation metrics, these metrics can tell how we can better prepare the model. And that's it. In this Jupyter Notebook demonstration, I've shown you the steps involving building and evaluating a life expectancy prediction model. I hope you find this demonstration informative and inspiring. Thank you for watching.